Hi, welcome to our channel of IGNOU Audiobooks, Indira Gandhi National Open University, School of Computer and Information Sciences, SOCIS, Postgraduate Diploma in Computer Applications, PGDCA, New. Semester I. MCS 201 Programming in C and Python. Block 1 An Introduction to C. Unit-3 Decision and Loop Control Statements. 3.0 Introduction. A program consists of a number of statements to be executed by the computer. Not many of the programs execute all their statements in sequential order from beginning to end as they appear within the program. A C program may require that a logical test be carried out at some particular point within the program. One of the several possible actions will be carried out depending on the outcome of the logical test. This is called branching. In the selection process, a set of statements will be selected for execution among the several sets available. Suppose, if there is a need of a group of statements to be executed repeatedly until some logical condition is satisfied, then looping is required in the program. These can be carried out using various control statements. These control statements determine the flow of control in a program and enable us to specify the order in which the various instructions in a program are to be executed by the computer. Normally, high-level procedural programming languages require three basic control statements: sequence instruction, selection decision instruction, repetition or loop instruction. Sequence instruction means executing one instruction after another, in the order in which they occur in the source file. This is usually built into the language as a default action, as it is with C. If an instruction is not a control statement, then the next instruction to be executed will simply be the next one in sequence. Selection means executing different sections of code depending on a specific condition or the value of a variable. This allows a program to take different courses of action depending on different conditions. C provides three selection structures: if, else, switch. Repetition looping means executing the same section of code more than once. A section of code may either be executed a fixed number of times, or while some condition is true. C provides three looping statements: while, do, while, for. This unit introduces you the decision and loop control statements that are available in C programming language along with some of the example programs. 3.1 Objectives. After going through this unit, you will be able to work with different control statements. Know the appropriate use of the various control statements in programming. Transfer the control from within the loops. Use the go to, break and continue statements in the programs, and write programs using branching, looping statements. 3. 2 Decision control statements. In a C program, a decision causes a one-time jump to a different part of the program, depending on the value of an expression. Decisions in C can be made in several ways. The most important is with the if-else statement, which chooses between two alternatives. This statement can be used without the else, as a simple if statement. Another decision control statement, switch, creates branches for multiple alternative sections of code, depending on the value of a single variable. 3.2.1 The if statement. It is used to execute an instruction or sequence block of instructions only if a condition is fulfilled. In if statements, expression is evaluated first and then, depending on whether the value of the expression, relation or condition is true or false, it transfers the control to a particular statement or a group. Of statements. Different forms of implementation if statement are: simple if statement, if-else statement, nested if-else statement, else if statement. Simple if statement. It is used to execute an instruction or block of instructions only if a condition is fulfilled. The syntax is as follows: if condition statement, where condition is the expression that is to be evaluated. If this condition is true, statement is executed. If it is false, statement is ignored, not executed. And the program continues on the next instruction after the conditional statement. If we want more than one statement to be executed, then we can specify a block of statements within the curly brackets. The syntax is as follows: if condition block of statements. Example 3.1. Write a program to calculate the net salary of an employee if a tax of 15% is levied on his gross salary if it exceeds hours 10,000 per month. Asterisk program to calculate the net salary of an employee asterisk. Hash include stdio. H. Main. Float gross underscore salary, net underscore salary. Print, enter gross salary of an employee \n. Scanf, %f, and gross underscore salary. If, gross underscore salary, 10,000. Net underscore salary is equal to gross underscore salary. If, gross underscore salary is equal to 10,000. Net underscore salary is equal to gross underscore salary 0.15 asterisk gross underscore salary. Print, \n net salary is hours %.2f net underscore salary. Output. Enter gross salary of an employee. 9,000. Net salary is 9,000 rupees. Enter gross salary of any employee. 10,000. Net salary is hours. 8,500.00. If, else statement. If, else statement is used when a different sequence of instructions is to be executed depending on the logical value, true false, of the condition evaluated. Its form used in conjunction with if and the syntax is as follows: if condition statement _1, else statement _2, statement _3, or if condition statements _1 block, else statements _2 block, statements _3 block. If the condition is true, then the sequence of statements _1 block executes, otherwise the statements _2 block following the else part of if-else statement will get executed. In both the cases, the control is then transferred to statements _3 to follow sequential execution of the program. This is shown in figure 3.2 given below. Look at the screen. Figure 3.2, if, else statement. Let us consider a program to illustrate if, else statement. Example 3.2. Write a program to print whether the given number is even or odd. Asterisk program to print whether the given number is even or odd asterisk. Hash include stdio. H. Main. INTX. Print, enter a number, \n. Scanf, %d, ANDX. If x%2 is equal to 0. Print, \n given number is even \n. Else. Print, \n given number is odd \n. Output. Enter a number, 6. Given number is even. Enter a number 7. Given number is odd. Conditional expression using ternary operator, happy smiley. There is another way to express an if-else statement is by introducing the ternary operator. In a conditional expression, the operator has only one Statement associated with the if and the else. The syntax is: variable is equal to expression 1, expression 2, expression 3. Example: hash include stdio. H. Main. int x is equal to 2. int y. Y is equal to x is equal to 6. 6 x. Print y is equal to %d y. Return 0. Output y is equal to 2. Nested if else statement. In nested if else statement, an entire if else construct is written within either the body of the if statement or the body of an else statement. The syntax is as follows: if condition underscore 1, if condition underscore 2, statements underscore 1 underscore block, else statements underscore 2 underscore block, else statements underscore 3 underscore block, statement underscore 4 underscore block. Here, condition underscore 1 is evaluated. If it is false, then statements underscore 3 underscore block is executed and is followed by the execution of statements underscore 4 underscore block, otherwise. If condition underscore 1 is true, then condition underscore 2 is evaluated. Statements underscore 1 underscore block is executed when condition underscore 2 is true, otherwise statements underscore 2 underscore block is executed. And then the control is transferred to statements underscore 4 underscore block. This is shown in the figure 3.3 given in the next page. Look at the screen. Figure 3.3, nested if else statement. Let us consider a program to illustrate nested if else statement. Example 3.3. Write a program to calculate an air ticket fare after discount, given the following conditions. If passenger is below 14 years, then there is 50% discount on fare. If passenger is above 50 years, then there is 20% discount on fare. If passenger is above 14 and below 50, then there is 10% discount on fare. Asterisk program to calculate an air ticket fare after discount asterisk. Hash include stdio. H. Main. int age. Float fare. Print \n enter the age of passenger. \n. Scanf %d and age. Print \n enter the air ticket fare \n. Scanf %f and fare. If age 14. Fare is equal to fare 0.5 asterisk fare. Else. If age is equal to 50. Fare is equal to fare 0.1 asterisk fare. Else. Fare is equal to fare 0.2 asterisk fare. Print \n air ticket fare to be charged after discount is %.2f fare. Return 0. Output. Enter the age of passenger 12. Enter the air ticket fare 2000.00. Air ticket fare to be charged after discount is 1000.00. Else if statement. To show a multi-way decision based on several conditions, we use the else if statement. This works by cascading of several comparisons. As soon as one of the conditions is true, the statement or block of statements following them is executed and no further comparisons are performed. Example 3.4. Write a program to award grades to students depending upon the criteria mentioned below. Marks less than or equal to 50 are given, D grade. Marks above 50 but below 60 are given, C grade. Marks between 60 to 75 are given, B grade. Marks greater than 75 are given, A grade. Asterisk program to award grades asterisk. Hash include stdio. H. Main. int result. Print enter the total marks of a student \n. Scanf %d and result. If result happy smiley 50. Print, grade D \n. Else if, result happy smiley 60. Print, grade C \n. Else if, result happy smiley 75. Print, grade B \n. Else. Print, grade A \n. Output. Enter the total marks of a student. 80. Grade A. 3.2 to the switch statement. Its objective is to check several possible constant values for an expression. Something similar to what we had studied in the earlier sections, with the linking of several if and else if statements. When the actions to be taken, depending on the value of control variable, are large in number, then the use of control structure nested if, else makes the program complex. There. Switch statement can be used. Its form is the following. Switch, expression. Case expression 1. Block of instructions 1. Break. Case expression 2. Block of instructions 2. Break. Default. Default block of instructions. It works in the following way. Switch evaluates expression and checks if it is equivalent to expression 1. If it is, it executes block of instructions 1 until it finds the break keyword. Moment it finds the control will go to the end of the switch. If expression was not equal to expression 1, it will check whether expression is equivalent to expression 2. If it is, it will execute block of instructions 2 until it finds the break keyword. Finally, if the value of expression has not matched any of the previously specified constants, you may specify as many case statements as values you want to check. The program will execute the instructions included in the default section if it exists, as it is an optional statement. Let us consider a program to illustrate switch statement. Example 3. 5. Write a program that performs the following, depending upon the choice selected by the user. I. Calculate the square of number if choice is 1. 2. Calculate the square root of number if choice is 2 and 4. 3. Calculate the cube of the given number if choice is 3. 4. Otherwise print the number as it is. Main. Int choice, n. Print, \n enter any number, \n. Scanf, %d, and then. Print, choice is as follows, \n. Print, 1. 2 find square of the number \n. Print, 2. 2 find square root of the number \n. Print, 3. 2 find cube of a number \n. Print, 4. 2 find the square root of the number \n. Print, enter your choice, \n. Scanf, %d, and choice. Switch, choice. Case 1, print, the square of the number is %d \n, n*n. Break. Case 2. Case 4, print, the square root of the given number is %f, sqrt, n. Break. Case 3, print, the cube of the given number is %d, n*n*n. Default, print, the number you had given is %d, n. Break. Output. Enter any number, 4. Choice is as follows. 1. To find square of the number. 2. To find square root of the number. 3. To find cube of a number. 4. To find the square root of the number. Enter your choice, 2. The square root of the given number is 2. In this section we had discussed and understood various decision control statements. Next section explains you the various loop control statements in C. 3.3 Loop control statements. Loop control statements are used when a section of code may either be executed a fixed number of times, or while some condition is true. C gives Your choice of 3 types of loop statements: while, do while, and for. The while loop keeps repeating an action until an associated condition returns false. This is useful where the programmer does not know in advance how many times the loop will be traversed. The do while loop is similar, but the condition is checked after the loop body is executed. This ensures that the loop body is run at least once. The for loop is frequently used, usually where the loop will be traversed a fixed number of times. 3.3.1 The while loop. When in a program a single statement or a certain group of statements are to be executed repeatedly depending upon certain test condition, then while statement is used. The syntax is as follows. While, test condition. Body underscore of underscore the underscore loop. Here, test condition is an expression that controls how long the loop keeps running. Body of the loop is a statement or group of statements enclosed in braces and are repeatedly executed till the value of test condition evaluates to true. As soon as the condition evaluates to false, the control jumps to the first statement following the while statement. If condition initially itself is false, the body of the loop will never be executed. While loop is sometimes called as entry control loop, as it controls the execution of the body of the loop depending upon the value of the test condition. This is shown in the figure 3.5 given below. Look at the screen. Let us consider a program to illustrate while loop. Example 3.6. Write a program to calculate the factorial of a given input natural number. Asterisk program to calculate factorial of given number asterisk. Hash include stdio. H. Hash include math. H. Main. INTX. Long int fact is equal to 1. Print, enter any number to find factorial. \n, asterisk read the number asterisk. Scanf, %d, ndx. While, x, 2000. Fact is equal to fact asterisk x, asterisk factorial calculation asterisk. X is equal to x1. Print, factorial is %ld, fact. Output. Enter any number to find factorial. 4. Factorial is 24. Here, condition in while loop is evaluated and body of loop is repeated until condition evaluates to false, i.e., when x becomes 0. Then the control is jump to first statement following while loop and print the value of factorial. 3.3. To the do while loop. There is another loop control structure which is very similar to the while statement called as the do while statement. The only difference is that the expression which determines whether to carry on looping is evaluated at the end of each loop. The syntax is as follows. Do statements. While, test condition. In do while loop, the body of loop is executed at least once before the condition is evaluated. Then the loop repeats body as long as condition is true. However, in while loop, the statement doesn't execute the body of the loop even once, if condition is false. That is why do while loop is also called exit control loop. This is shown in the figure 3.6 given below. Look at the screen. Figure 3.6, the do while statement. Let us consider a program to illustrate do while loop. 3.3.3 The for loop. For statement makes it more convenient to count iterations of a loop and works well where the number of iterations of the loop is known before the loop is entered. The syntax is as follows. For initialization, test condition, increment or decrement. Statements. The main purpose is to repeat statement while condition remains true, like the while loop. But in addition, For provides places to specify an initialization, instruction and an increment or decrement of the control variable instruction. So, this loop is specially designed to perform a repetitive action with a counter. The for loop as shown in figure 5.7 works in the following manner. 1. Initialization is executed. Generally it is an initial value setting for a counter variable. This is executed only once. 2. Condition is checked. If it is true the loop continues, otherwise the loop finishes and statement is skipped. 3. Statements are executed. As usual, it can be either a single instruction or a block of instructions enclosed within curly brackets. 4. Finally, whatever is specified in the increment or decrement of the control variable field is executed and the loop gets back to step 2. Let us consider a program to illustrate for loop. Example 3.8. Write a program to print first in natural numbers. Asterisk program to print first in natural numbers asterisk. Hash include stdio. H. Main. INTI, N. Print, enter value of n \n. Scanf, %d, and then. Print, \n the first %d natural numbers are, \n, n. For, I is equal to 1, I is equal to n, plus I. Print, %d, I. Output. Enter value of n. 6. The first 6 natural numbers are 1, 2, 3, 4, 5, 6. The 3 statements inside the braces of a for loop usually meant for one activity each, however any of them can be left blank also. More than one control variables can be initialized but should be separated by comma. Various forms of loop statements can be A. For, condition, increment decrement. Body. A blank first statement will mean no initialization. B. For, initialization, condition. Body. A blank last statement will mean no running increment decrement. C. For, initialization, increment decrement. Body. A blank second conditional statement means no test condition to control the exit from the loop. So, in the absence of second statement, it is required to test the condition inside the loop, otherwise it results in an infinite loop where the control never exits from the loop. D. For, increment decrement. Body. Initialization is required to be done before the loop and test condition is checked inside the loop. E. For, initialization. Body. Test condition and control variable increment decrement is to be done inside the body of the loop. F. For, condition. Body. Initialization is required to be done before the loop and control variable increment decrement is to be done inside the body of the loop. G. For, body. Initialization is required to be done before the loop, test condition and control variable increment decrement is to be done inside the body of the loop. 3.3.4 The nested loops. C allows loops to be nested, that is, one loop may be inside another. The program given below illustrates the nesting of loops. Let us consider a program to illustrate nested loops. Example 3.9. Write a program to generate the following pattern given below. 1. 1, 2. 1, 2, 3. 1, 2, 3, 4. Asterisk program to print the pattern asterisk. Hash include stdio. H. Main. INTI, J. For, I is equal to 1, I is equal to 4, plus I. Print, %d \n, I. For, j is equal to 1, j is equal to I, plus j. Print, %d \t, j. Here, an inner for loop is written inside the outer for loop. For every value of I, j takes the value from 1 to I and then value of I is incremented and next iteration of outer loop starts ranging j value from 1 to I. 3. For the goto statement. The goto statement is used to alter the normal sequence of program instructions by transferring the control to some other portion of the program. The syntax is as follows. Goto label. Here, label is an identifier that is used to label the statement to which control will be transferred. The targeted statement must be preceded by the unique label followed by colon. Label, statement. Although goto statement is used to alter the normal sequence of program execution, but its usage in the program should be avoided. The most common applications are I, to branch around statements under certain conditions in place of use of if-else statement. 2. To jump to the end of the loop under certain conditions by passing the rest of statements inside the loop in place of continue statement. 3. To jump out of the loop avoiding the use of break statement. Goto can never be used to jump into the loop from outside and it should be preferably used for forward jump. Situations may arise, however, in which the goto statement can be useful. 2. The possible extent, the use of the goto statement should generally be avoided. Let us consider a program to illustrate goto and label statements. Example 3.10. Write a program to print first 10 even numbers. Asterisk program to print 10 even numbers asterisk. Hash include stdio. H. Main. int I is equal to 2. While 1. Print %d I. I is equal to I plus 2. If I is equal to 20. Go to outside. Outside, print over. Output 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 over. 3.5 The break statement. Sometimes, it is required to jump out of a loop irrespective of the conditional test value. Break statement is used inside any loop to allow the control jump to the immediate statement following the loop. The syntax is as follows. Break. When nested loops are used, then break jumps the control from the loop where it has been used. Break statement can be used inside any loop, i.e. while, do while, for and also in switch statement. Let us consider a program to illustrate break statement. Example 3.11. Write a program to calculate the first smallest divisor of a number. Asterisk program to calculate smallest divisor of a number asterisk. Hash include stdio. H. Main. int div num I. Print enter any number \n. Scanf %d andnum. For I is equal to 2, I is equal to num plus I. If num %i is equal to 0. Print smallest divisor for number %d is %d num I. Break. Output. Enter any number. 9. Smallest divisor for number 9 is 3. In the above program, we divide the input number with the integer starting from 2 onwards and print the smallest divisor as soon as remainder comes out to be 0. Since we are only interested in first smallest divisor and not all divisors of a given number, so jump out of the for loop using break statement. Without further going for the next iteration of for loop. Break is different from exit. Former jumps the control out of the loop while exit stops the execution of the entire program. 3. 6. The continue statement. Unlike break statement, which is used to jump the control out of the loop, it is sometimes required to skip some part of the loop and to continue the execution with next loop iteration. Continue statement used inside the loop helps to bypass the section of a loop and passes the control to the beginning of the loop to continue the execution with the next loop iteration. The syntax is as follows. Continue. Let us see the program given below to know the working of the continue statement. Example 3.12. Write a program to print first 20 natural numbers skipping the numbers divisible by 5. Asterisk program to print first 20 natural numbers skipping the numbers divisible by 5 asterisk. Hash include stdio. H. Main. INTI. For I is equal to 1, I is equal to 20, plus I. If I%5 is equal to 0. Continue. Print %d, I. Output 1, 2, 3, 4, 6, 7, 8, 9, 11, 12, 13, 14, 16, 17, 18, 19. Here, the print statement is bypassed each time when value stored in I is divisible by 5. 3.7 Summary. A program is usually not limited to a linear sequence of instructions. During its process, it may require to repeat execution of a part of code more than once, depending upon the requirements or take decisions. For that purpose, C provides control and looping statements. In this unit, we had seen the different looping statements provided by C language, namely while, do, while and for. Using break statement, we can leave a loop even if the condition for its end is not fulfilled. It can be used to end an infinite loop or to force it to end before its natural end. The continue statement causes the program to skip the rest of the loop in the present iteration as if the end of the statement block would have reached, causing it to jump to the following iteration. Using the goto statement, we can make an absolute jump to another point in the program. You should use this feature carefully since its execution ignores any type of nesting limitation. The destination point is identified by a label, which is then used as argument for the goto instruction. A label is made of a valid identifier followed by a happy smiley. Thank you for watching. We will see you in the next video with the next chapter.